Think we can start. Hello, everyone, and welcome to today's session. Thank you for joining us for today's session. And my name is Gineesh, and you can call me Guinea. Today we have a very interesting topic where we are going to learn how to use Ansible for Linux file system management. So Maithili Sharan will share with us how to do this, what are the best practices, and we will have a demonstration as well. Um, Before we proceed, this session will be recorded and you can access the same session using the same URL. So yeah, if you miss a session, you can watch it anytime later. Then another important thing is like you can always or you can ask the question anytime. Please ask your question in the chat box and we will try our best to reply on that. And if you have any questions later, you can ask in the comment box in YouTube video comment box. We will, of course, we will try our best to answer those. I think I don't need to waste our time. So, Sharon, yeah, the stage is yours.
Awesome. Thanks, Jenny. Hello, everyone. My name is Maithili Peetani. Um, um, Currently, I'm working as a cloud engineer, but I have around 5 years of experience on Ansible and 11 years experience on Unix and Linux engineering. So today I'm here to present about the how we can use Ansible for Linux file system management. So as you know, everyone know what is a file system and what comes under file system hierarchy. Like, it has a disk, the format of the disk, and the mount point, and how we make it like consistent, like making like accessible to the users with all the needed permissions. So the modules we use for this task are like, there are some modules or Ansible modules which we use them. So the first module is the LVG. It is basically used to configure, the LVM volume groups. And the parted module is the one where you can partition your disks, any disk partitions you want to, like GPT or MS-DOS or, any F-disk utility. And LVOL is used to configure your logical volumes, like create logical volume groups or extend the volume groups or shrink the volume groups or snapshot your logical volume groups. And the file system module is the one where you use to format your needed format the file LVM to your needed format, like any like ext4 or XFS file systems. And the mount module is used to mount your file system to the respective mount point. And there are some options available in the mount module where it has like, to mount it, basically making sure it makes persistent of the mount point, and it mounts the file system, remounted, unmounted, absent, or present. And I'll walk through those options in the demo. So there are some use cases where I picked up, like, how you can create a disk partition, how we create a volume group, logical volume, and how we create a file system, and how we mount a file system. And once we have those, like, how we're going to resize it, which is like, it has both extend or shrink the LVM, take the snapshot of the LVM, and some Ansible facts where it has, we can collect about host devices facts or mounts or LVMs. So let's go and show you the demo how we do the disk partition. So my first playbook is very basic playbook where we just, the steps we discussed. We're going to partition the disks and create a volume group and create a logical volume group and format the volume group and then mount the volume group. I commented the last two tasks. One is like for the extend and one is to the shrink. We're going to do that once we create the LVM. I mean, for the next use case. But so the first task, which I mentioned, is a partition the disk. So we're going to use the parted Ansible module, and we're going to give the device the disk name, which is basically one of the disks I have on my target nodes, and the number. What is the partition number? So it's going to be std1, and the flags basically we're going to use for the LVMs and the state present and where the partition to end. So my disk, I have a 5 gigs disk, so I'm going to make it like a 4 gig. And the next is the LVG module, which is used to create the volume group. So the VG, basically naming the name of the VG volume group we want to create. It's going to be VG01. And the PVS is the physical volume. So we're going to provide our partitioned disk. It's going to be /dev std1, and the PE size of the volume group. So I'm going to make it like 16. And once the volume group is created, the next task is going to be to create the logical volume. And we're going to use the module lvol. And here it needs the volume group name information, which is given as VGO1 in the previous task, and the LV name. So we're going to give like LV test, the size as 1 gig, and yes to create it. And next we're going to format the LVM into XFS file system. So for this, we're going to, as I mentioned before, we're going to use file system module, and then FS type, basically what format we're going to use it. So I'm going to give as a XFS, and the device is our volume group and the LVM device path, and mount it. So to mount it, we're going to use the mount module and the path. So basically the path is, I'm just picking up as mount 1, and the source is our LVM device source. And the FS type is again XFS, and the state mounted. And we can also add options as default. So default meaning basically like what are default options we have in the OS. So if you go ahead and run, before I do, let me check. I'm able to access my server, and the other thing. Okay. All right, so let's go and as you can see, it created the partition. What happened? I'll show you the options part later. All right, so as you can see, it created a partition, then it created a volume group, then it created the logical volume, then it formatted the LVM, and then it mounted it. So let's go into the server. This is my server, and first thing to check if it created the previous, the physical volume, and we can see it has created a physical volume, and also it partitioned the disk dev std to std1 with size 4 gigs. And to check the volume group, we use vgs command, and you can see the volume group vgo1 is created with the size we mentioned, the disk size, and LVS to check the logical volume, and we can see the one we provided was LV test with 1 gig. And when I list the file system list, I can see my LVM is mounted to mount one mount point, and it also made persistent in the FS tab entries. As you can see, it added the logical volume, mount point, XFS, and defaults, and the mount, the dump, mount options, dump and pass no options. So this is like a standard way of creating, straightforward way of creating your LVM. So let's see. Let's extend. Let's extend this volume group. As I mentioned, so again, to extend the volume group, we use the lvol module, and here we're going to provide again the same volume group, lv name, and the size we want to extend it to. So currently we have 1 gig. This is my server. So as you can see, this is our volume group, and we have still around 2.72 gigs free space available, and we created our logical volume with 1 gig, and so the the file system size is 1 gig. So let's add 1 more gig. So let's make it to 2 gig, and we'll see what happens now. And there are some options which I'm after when we create a logical volume like command line, we resize the file system, which means updates the mount point size too. It's not only updating the logical volume, it also updates the mount point size too, and force yes to make sure it updates the mount point. And when you run the playbook, and the remaining tasks are okay because it's already created it, and you can see it has changed the, when we extend the logical volume. And let's go and verify it on the server. If you can see, it updated the file system size, and also our LV test size has been increased to 1 gig, sorry, 2 gig from 1 gig. And as you know, the volume group now has only 1 gig free space available. So say now we want to shrink the LVM. I'll come back to my playbook. Generally, it's not suggestible to shrink the volume group in enterprise or any organization or any production servers, but just for the demo purpose, I'm showing it. So what I'm doing is, like, again, I'm going to use the lvol Ansible module, and the volume group name, lv size, sorry, lv name, and the size of the volume. So to which size we're gonna reduce it to. So I'm gonna say 700 MB and shrink yes, and force and resize it. So when we run the playbook again, oh, okay, because we used XFS. Okay, try one more time. Okay, so you can see the LVM has been reduced to 700 MB. Volume group got the space back. So this one is not. So it shrink the volume group back to 700 MB as we mentioned, but as I said, it's not a suggestible option to shrink the logical volume. Um, so this is how we create a logical volume and extend the logical volume and also shrink the LVM of your needed size. So uh, so this playbook we created, we got the use case like how to create the disk partition, how we create the volume group, and how we create a logical volume, create the file system and mount it, and then we did a resize. But we have another playbook. Say we have a multiple playbook, multiple logical volumes and multiple volume groups to be created, and they partition them and use uh, different kind of mount options. Like as I mentioned, according to Ansible doc, we have mounted, present, and remounted. So so this is the playbook where I'm using VAT, the variable file here. And the first task going to be, create the partition from the list provided as per the variable files. And then the next step going to be create the volume groups, and again create the logical volumes, and then format the volume groups, and then mount the logical volume with the inputted mount point, and then apply the needed permissions as I mentioned. One thing you might be noticed, like why I'm not creating the mount point here. So if in the mount module, if you mention the state as mounted, the mounted option creates the mount folder, and also it updates the fstab. And if you mention just the present, it just creates only the fstab entry, but it won't create the directory. So the task will fail, saying like, this mount is not exist because the folder is not created. And we use remounted option for the state when we want to make some, say for example, you want to make some mount options changes, then we use state remounted. So what it does, it refreshes the mount. So basically it updates the fstab entries with whatever options we provided, and then it refreshes the mount point and it mounts the mount point back on the server. Again, we're going to use the same modules with our tasks we have. So we're going to use the parted module. We're going to provide the device, which is our /dev SD disks, and the number where it has what the partition number going to be, and where the partition going to start and where the partition going to end, and the state present, and the flags obviously going to use the Lvms. So we're going to give the Lvm flag, and I'm using a loop control here because of the variable. I'm going to show you the variable file in a moment, and I'm going to control the loop control label with the needed physical volume. And then I'm going to use the volume group module, which is LVG, to create the volume groups. And again, I'm going to input the VG name, the physical volumes name, and the state obviously needs to be present. And once the volume group is created, we're going to create the logical volume. So for create logical volume, we need the volume group information, the LV name, the size, the state of the LV, the logical one. So basically, it's going to be the present, and resize it, and of course, we'll create it if any changes need to be done. And again, I'm looping the variable from the using the input variable LVM LVS, and then format the file systems. So format the file system with the inputted formatter version, and the device basically is going to be our LVM device. And again, information from from the variable file, and then mount it with all the what is the source, what's the path, what kind of file system type, and the options, and the what kind of dump options, pass no options, and the state. And then apply the permission. Say we have some application users where they need owner and group membership, and what kind of permissions they need. So for this, we're going to use the file module, path of the mount point, who is going to be the owner and the group, the mode, basically the permission is going to be either 755 or any kind of permissions we want to. And I'm going to looping up the variable with LVM LVS. So that's the playbook, but and this is the variable file, as I mentioned in the playbook. So the first going to be the LVM PVS, where it's going to get the information, what is the PV name, basically about the disk name, where the number going to start from, and start from 1 MIBN to the 3 gigs. And then, so basically we're making the same disk, 3 partitions with each going to be 3 gigs. So I'm going to start from 1 to 3, and then 3 to 6, and 6 to 9, and also making SDC 1 partition with 2 gigs. And this is the volume group informations where we're going to create using the LVM VGS. This is VG going to be the volume group name and the physical volume that it needs to be created with. And again, VG04 is another volume group, and these are the physical volumes that needs to be created with the disks. And this is the LVM informations. So basically, LVM information is needed, what volume group it needs to be created under. So it's going to be the volume group name and the LVM name and the size and the mount where it needs to be mounted to, and mount who is going to be the owner, and the group after the mount point is mounted and providing the permissions. Same thing, mount mode is a permissions, and I'm giving the dump option as 1 and 2, and mount options I'm just leaving as defaults, and the state mounted here. So basically mounted meaning it's going to create the data folder on the server, and then it's going to make it persistent by adding into the FS tab, and the file system type is XFS. So basically I'm creating one of the data volume group, and the other one going to be web volume group. So it's going to create another volume group, LVM name, size, everything going to be same. The only thing difference between the previous input and this one is I added some mount options where like read, write, no execute, like generic mount options, and the state I gave only present. When I execute the playbook, you can observe one thing, it's going to fail when it's applying these permissions. Why? Because this option, as I mentioned earlier, it makes only the persistent option by adding into the FS tab, but it won't create the folder. So which you're gonna see when I execute the playbook. And I'm creating another group called, LVM called LV log under the same volume group VGO4 with all the defaults options again. So I'm gonna go ahead and execute this playbook. So as you can see, it created the partitions for SDB and SDC. It created the volume groups VGO3 and VGO4, and created the logical volumes as we inputted, and then it also formatted the LVMs to the needed format versions, and then it mounted the file systems. And one thing you observe is like to apply the permissions. So it applied the permissions to data and the log, but it failed because the /web not exist on the server. So let me show on the target server how the present option gonna look like. When you check the etc fs tab entries, you can see like the first /data has been included with the default options, and /web with a /web LVM /web /web mount point, what kind of mount format it has, and the options, and the all the needed options. So everything exists in the FS tab, but when I want to check, as you can see, it is not created yet. So present basically makes updates in the FS type entries, but it will not create, the folder, the mount point folder. But for the remaining ones, since we gave us the mounted options, it created both the data and the log mount points, and then it mounted the file system. So if you want, you can change it back in our variable file. Say, let's use remounted, and say I want to remove. So for the web content, let's say we remove one of the mount options and make this one as remounted. And let's see the changes, what happens now. Oh, okay, my bad. I need to mount it because the folder is not created. As you can see, now it made the mount point changes. So let's go and see on our server. See, now it created the folder, and also it mounted the web mount point now with the needed space. So let's go and try the option remounted and make some mount point changes. So for that, I came back to my control server, and I'm going to the variable files. And let's say I'm going to remove one of the mount options and make this as remounted. So I'm executing the playbook again. So everything gonna be okay because it's already created. So let's run again. Just putting back to the mounted option and see what happens. Oh, because it's already mounted. So let's create a new playbook with a mounted option, a remounted option actually, because it's not changing it. That means it's already mounted. I need to provide. So for this, we're going to use the mount, and the path is mount1. So it's going to be /dev our volume group and the volume group. FS type is ext4. So the options, let's say we remove the no SUID. The dump one and sorry, that's now is 2 and state is remounted. So let's try this one. Okay, that I need to put in the strings, but it's supposed to update, remove this mount point, but either way, I'm sorry about that. Uh, this is how you want to use a remounted option. Basically, it updates whatever option you want to make the changes. So it remounts a file system with the new options or any changes we want to make it. So this is how you create multiple volume groups or LVMs with your needed options. And so this cover this one, and yeah. So the last thing I want to show is say we want to extend the swap file swap LVM. So for this, I'm going to, again, since our swap is a LVM, so I'm going to use the Ansible LVOL modules, and some of the modules I'm going to show you, walk you through. So for this, I have a variable file where I inputted all the LVM names, swap file system types, and all these things I'm going to show you in a second. And this one, first one shows the current swap size in gigabits. So we have a Ansible nice fact variable for the swap, where it shows the total swap total into the MB size, which I'm converting this into the GB gigabytes. And the first thing to extend the swap size is we have to turn off the swap. So I'm using the command swap off -a, and this condition basically means making sure when swap has more than 0 size, so making sure the swap is running. If not, swap is turned off. So I'm refreshing the facts. And then since the swap on the server is an LVM, I'm going to use the LVOL logical volume, and So for that, we're going to input the volume group, the LV name, and the size. The state is present, and again, I'm looping the variable we have in the variable file, and then we're going to format the swap using mkswap. So for this, I'm going to use the command module, and then we're going to add it back. Actually, we don't need this one because we're not removing it. And then once the swap is formatted, all we do is like just turn on the swap, because, and this command runs on a condition basically because we turn it off the swap, it's going to be in the 0 size. So obviously the fact variable going to show the value as 0. So basically swap on executes only when the swap is 0, or else it's going to skip it. And once it's done, we're going to refresh the Ansible facts, and then it's going to show us the new swap size. So, and this is a swap variable file where I gave element swap as input one, and the name of the swap volume group, which is under VG00, and the swap LV name, and the swap size we wanted to, and FS type. So before we extend the swap, let's go and check the current swap size. So for this, I'm on the target server. I'm running free -m. So here you can see it's currently at 2 gigs. And you can also verify the FS-tab entry it has, and we can see it already has a FS-tab entry, so we're not going to touch anything. And we're going to check the swap LVM size, which is 2 gigs. So basically, we are trying to add 1 more gig. So basically, we are extending this one to like 3 gigs now. So let's go and execute the playbook. So as you can see, first it printed out the current swap size, which is 2 gig, as we verified on the target server. And then it disabled the swap, and then it refreshed our Ansible facts. It extended the volume group LV swap, and then it formatted using mkswap, and then it turned on the swap, and then refreshed it. And here is our new swap size, which is 3 gigs, and we can verify this. And you do lvs command, and you can see it has 3 gigs. And also the new swap size utilized is 3 gigs now on the server. And yeah, and another playbook, say you want to know any disks or mounts existing on the target server without logging. So I have a playbook which is Ansible facts. Oh, sorry about that. I need to show. Let me show you the playbook. So the first is I'm kind of set facting the variables like mount points and mount devices. So basically for this, Ansible has a very good facts for the mount, which is Ansible mount. And if you want to know any device information, we have Ansible devices. And if you want to know any LVM informations, you can use Ansible_LVM. So let me show you them. Say I'm running an ahead command. Say you want to see what device you have on the target server. So all I'm doing is Ansible all -m, the setup. Sorry. So -m setup, and we're using the filter Ansible_devices. So basically it lists all the current devices exist on the target server. So let's execute that. So as you can see, say let's pick one disk. So yeah, so as you can see, this is Ansible facts and this is Ansible devices. So it shows all the disks or not only disk, any devices like any CD-ROM or anything or existing volume groups, everything can be listed out of these Ansible devices. So you can see volume group information, root volume group information, and the sizes, disk partitions information, everything can be listed in this fact variable. I'm gonna show. So let's say SDA, for example. So SDA is basically our boot disk, but it shows all the partitions information. So SDA has SDA1 partition and SDA partition, the ID, and what device it's going to use. If it is a part of LVM, every information is listed in this one, and how much size of the partition and which volume groups are using it. So for example, SDA3 is an LVM partition, and you can see it shows all the volume group and the LVM informations here. And what the link, so link is basically with the respect of the DM, the master DM links to the SDA3, and what is the size of the SDA3, which is like 39 gigs, and where it started from. So Ansible underscore device is a very good fact variable, which has all the information you needed. You're looking for, it has all the information you needed, especially for the disks and device information. And the next one I mentioned is Ansible underscore LVMs. Say you want to know any LVM information on target server. It's the same command again, Ansible all -m setup -a, and we filter the setup fact with Ansible underscore LVM. And once you execute that, you can see you get a very nice output with all. So it has LVS basically LVM information and LVM name, what size and which volume group it belongs to. So you can see all LVMs on the target server. So we created part of the demo, we created LV Web 1. It shows the size of the LVM and in which volume group it has been hosted with. Same thing with the physical volumes. You can see physical volumes and all the physical volumes the server has, like SDA3, V1, V2, and how much free space it has, what is total size, and which volume group it has been created with. And same thing with the volume group. So we created, as part of the demo, we created like VG 01, 3, and 4. And so name of the volume groups and how much free space the volume group has, how many LVMs has, how many physical volumes the volume group has, and the total size of the volume groups. So this is like a good detailed information if you want to know anything before you want to work on the servers, like and create your LVMs, anything based on with this information. And the next fact variable is Ansible underscore mounts. Basically, this one is used to check the existing mount point information on target server. So let me scroll up. So as you can see, the first one is the mount point, the root mount point, and it can show the blocks available, the total block size, and what device it has been mounted with. So this is like LV root, and what file system type, and the inodes information, and what options, mount options it has been mounted with, and how much size is available. So this is like in the byte, so we can convert it like with available filters we have, and the total size of the mount point, the file system. So it lists every mount point exists on the target server. So for example, so this is one of the file system we created part of the demo. So this is the device information, the file system type information, the mount point information, and the options, mount options have been mounted with, and the free size available, and the total size it has been created with. So these three are very good Ansible facts, which are very useful when you're creating the file systems or any disk partitions, anything, we can make sure to get the information from these facts and use it and make it more idempotent with these fact variables. So So I created like a sample playbook where it based on the fact variables we have, like I'm collecting the mount points information and the LVM devices connect mounted with the mount points, and I'm debugging those outputs, mount points, and mount devices. And the other one is listing all the existing volume groups, just the volume group name and the total size, and the disks that are attached to the server. And I'm here. I am uh, not listing SDA because we know SDA is part of the OS disk. So let's execute this playbook and see what the output looks like. So the first task was to list all the uh, LVMs available. So as you can see, we got all the LVMs exist on the target server. Same thing, the mount points exist on the target server. And here you can see we got VG0 has this much filtered out, like total size of this much, VG01 total size, 3 total size, and VG04 total size. And then as we excluded STA, so it's going to show the remaining disks that has been allocated to the server. So we can see like we have SD, B, C, and D. Um, so this is how we can use the Ansible facts and filter out the needed options with respect to resource, like any volume group or the Ansible mount points, Ansible mount free spaces, and everything. So we covered snap. Oh, the last one we have is a snapshot. As we know, snapshot, we basically use snapshot like to have a mirror image of the existing volume group. So here I'm using again the the LVOL Ansible module and the volume group VGO1, and we have our volume group LV test and the size of the snapshot and the snapshot name. So I just imported that information for the demo purposes, but as you can see, I'm on the target server now. So I'm trying to create LV test LV test LVM snapshot in their VGO1 volume group. So and I'm creating the snapshot size as 350 MB. So let's go and execute the playbook. So you can see it created the changed, basically meaning it created a snapshot. So we can verify it using LV display command, and LV test is a volume group we created. Sorry. So when I check the LVM display information, you can see it has a snapshot status. It has a source of snap1 is the one which we put it, and it is active. And you can also see when you do LVS, this is our LVM, and this is a snapshot we created for the LV test. And once it is there, you can mount the snapshot volume, and you can take a backup of any LVM or any, like basically use a tar command. We can restore it, anything, and once it is done, we can delete it. So this is how you can use the same module, and LVOL has so many other options. Not only snapshot, but other options available. Also linked in the slides, all the Ansible modules links for all the modules we used. So these are the use cases I covered for every option we have, and this concludes our demo. And if you have any questions, you can answer it.
Okay, thank you so much, Maithili, Sharan. So this one was a great session. Actually, we have covered almost all items like creating the volumes, formatting the file system, mounting these on your operating system, everything you had done. I think we can take some time for answering the questions. Actually, there are a few questions I can see already. Um, One question is there a way we can convert the size available to human-friendly format in Play itself from Raman?
Yeah,
Um,
we can, as I showed you in my previous playbook, so you can use the available options. Uh, uh, sorry, give me. So you can see you can use, like, since the mount point options are going to be in the bytes, you can convert them dividing 1024 is a basic number, and that converts to your needed uh, unit, like megabytes or gigabytes, and then, like, you can output it any way you want it to.
okay, I think that's very good actually. That's a very useful one. Yeah, I
Yeah.
think that's the answer. Yeah, it's possible. We can use that kind of method. Tricky,
Like,
but it's working. It will work.
all you need
And
is just convert the unit number,
yeah,
whatever
correct.
you got it. Yeah.
Yeah. Okay, thank you. Another question is from Nagarjuna. Suppose in cloud we add the disk. So his question is, how can we use Ansible to use this disk and create file system? I believe it's the same. Maybe Sharon can answer.
Yeah. So once you add the disk, you can run the Ansible facts, as I showed you, the Ansible devices, where it shows all the disks available on the server, and then you can use those disks, and you can use it for your LVM management.
Yeah, so it will be same. I mean, I don't think there will be difference because it's all from the operating system side, right?
Mhm. Yeah.
So yeah, it will be same. It will be same as the normal one.
And
So
another thing, if it's a Linux server and you added a new disk, you need to do is a scan the disk. We have the command host scan command, and then it shows the new disk added to the server. Then you can list the disk and uh, you know do the LVM management.
yeah, yes, you can scan and get the additional disk or the latest disk added, and you can use that fact to proceed with your creation of the volumes, kind of thing.
Mhm.
Okay, that's good. I got another via personal one. Okay, what about the Windows? Uh, yes, Windows, we have equivalent modules for this one called kind of a Win partition, Win disk image,
Yeah.
etc. You want to explain anything on that one?
Um, so this session is only for the Linux. There
Yeah.
are some modules available for the Windows, and those are available in Ansible docs. Um, I will put in some links in the presentation. Maybe you can reference from
Okay.
the.
Yeah. Yeah, that would be great. Yeah, actually, we have equivalent kind of the Win partition, Win disk image, Win format. Most of
Mhm.
them are there, so we have to use it appropriately. So yeah, often is there still it's supposed to, even we can manage all Windows file system thing, same like Linux, but not in our today's scope. Yeah, but we will try to include the links or those references in the slides and also in the inside the video description. Sure. Um, Great. Is there any other question we missed? Um, I don't think we missed any other questions.
Okay.
Uh, yeah, I think all good. Before we wrap up, you want to add anything?
No, I'm good. I'm gonna put all these codes in the GitHub repo, and I'm gonna share it after the session.
Okay, okay. Thank you so much. So yeah, that will be great. So you can refer the GitHub repo from the video description later. We will add that, and you can refer that. So you can just practice, and you just find your use cases from your workplace. And if you feel like some issue, always ask in the comment box, or you can just uh, submit the topic suggestion in the feedback or questions, anything. Also, once if the video is published, you can ask in the comment box. We will try our best to answer the question. So um, this actually, thank you so much for that one. So if you have any feedback, please you can scan these and submit the feedback, or just type the URL So you can also suggest the topics for our next session. So usually we collect this topic from the community. Someone says, okay, this is how we can do this and all. So already we got a topic from today's chat. Someone asking for the Terraform with Azure. So we can cover that one day as an introduction. And if anyone you want to present or something, you're always welcome. Please let me know. And subscribe to the channel. You will get more and more videos like this. And we have a few more sessions already scheduled. And our next session is on this Friday, on this Saturday, which is like we will just give an introduction for how to use Ansible for infrastructure provisioning in AWS. So this will be an introduction how to use Ansible to provision the resource, including easy to keep all those things, whatever we need. So we are not going to replace Terraform with Ansible. Instead, we will explain how to use Ansible for doing almost same thing in case some maybe there might be some use cases to use only Ansible without Terraform. Okay. I think that's it. We are pretty good. If no other items to discuss, I think we can wind up. And thank you so much again, Maithili. It was a great session. So we have covered almost all things. And thank you all for joining, watching, listening, and for your support. Um, See you all next time again with another interesting topic. And I think we are good. We can call it a day if no other questions. Anything for the last round? No other questions. Thank you. Thank you so much for joining. And
Thank you, guys. Appreciate all
okay,
for.
thank you all. Stay safe. Take care. Thank you all. See you. Bye bye.